Okay, so let's kick things off with the real basics. There's three main types of rocks we got here on Earth, and how we tell them apart is all in how they're made, see? We got igneous, sedimentary, and metamorphic rocks. Each one of them comes to be in its own special way, and that's what makes them so different from each other. So, next up, let's dive right into igneous rocks. Now, igneous rocks are pretty cool because they come from fire. Well, sort of. They form when hot, molten lava or magma cools down and hardens. There are two ways this happens. First, they're intrusive or plutonic rocks, like gabbro. These form when magma cools slowly deep beneath the surface, giving them a coarser, chunkier texture. Then we have extrusive or volcanic rocks, like basalt. These form when lava erupts onto Earth's surface, like from a volcano, and cools quickly, making a fine-grained texture. So the speed of cooling really shapes what kind of igneous rock you get. So, let's chat about what igneous rocks are actually made of. Now, we can group them based on their silica content. That's a mineral that affects their color and weight. First, we get felsic rocks, like granite or rhyolite, which abundant silica over 65%. They're lighter in color and full of light minerals. Next, intermediate rocks, like diorite or andesite, have a bit less silica, say 55 to 65%, and they're a mix of light and dark minerals. Then we have mafic rocks, like gabbro or basalt, with 45 to 55% silica, which makes them darker and just packed with heavier minerals. Finally, ultramafic rocks, like peridite, have the least silica, less than 45%, and they're super heavy. So, the key thing to remember, the texture of the rock tells us how fast it cooled, and the composition tells us what it's made of.
All right, let's move on to our second class of rock, sedimentary rocks. These rocks are like nature's storytellers. They form from bits and pieces of other rocks, minerals, or even ancient plants and animals that pile up over time. Think of it like layers of sand, mud, or tiny shells settling down in places like riverbeds, oceans, or deserts. Over millions of years, those layers get squished and hardened into rock. Let's look at a few examples. Sandstone comes from grains of sand sticking together, like what you'd find in a desert or beach. Limestone is often made from tiny sea creatures' shells piling up on the ocean floor, and you'll also see it in places like caves with stalactites. And then there's coal, which forms from ancient plants in swampy forests that get buried and compressed over time. So, sedimentary rocks are all about layers and leftovers from the past. Sedimentary rocks come in three main flavors, depending on how they've developed. First up, we have sedimentary rocks formed by physical means, like sandstone and shale. These form when bits of rock and sediment, like sand or gravel, get carried by wind, water, or ice, then settle and get squished together. They're usually grainy and plastic, which just means they're made of little fragments. Next, we have sedimentary rocks that are formed chemically, like limestone and gypsum. These form when minerals dissolve in water, like in the ocean, and then the water evaporates, leaving the minerals behind to harden into rock. They often have a smooth, crystalline texture, like what you'd see in a cave. Finally, we have sedimentary rocks with biological origins, like coal and chalk. These are made from the remains of living things, like shells, bones, or pieces of trees, that pile up and harden over time. Their texture can vary, sometimes grainy, sometimes smooth, and they're often full of fossils. So, sedimentary rocks are recycled bits of the earth into something new.
Okay then, let's talk about our third type of rock, which is metamorphic rocks. These rocks are like the transformers of the rock world. They start as other rocks, maybe igneous or sedimentary, but then they get changed deep inside the earth. How? It's all about heat and pressure. Imagine rocks buried deep under the ground, getting squeezed by the weight of all the layers above them. That's the pressure, and it also generates heat. At the same time, they're getting heated up by Earth's hot interior. This combo of heat and pressure changes the rocks, baking them into something new. They don't melt though, they just transform, or metamorphose, into a different form with new and altered minerals and textures.
Okay, so now that we've covered how metamorphic rocks take shape, let's dive into the different kinds. We can group them based on how they look and what they're made of. First up, we've got foliated rocks like slate, schist, and gneiss. Now, foliated just means they've got thin layers or bands. Think of them like a flaky pastry. This happens because of the pressure squishing them into thin layers over time. Slate, for instance, comes from shale and is super smooth, often used for roofing tiles. Schist and gneiss have more sparkly minerals and distinct bands. Then, we've got non-foliated rocks, like marble and quartzite. These don't have layers, they're more solid and uniform. Marble comes from limestone and is often used for statues because it's so smooth and pretty. Quartzite comes from sandstone and is super hard, often used in construction. So, metamorphic rocks are all about transformation. Heat and pressure turn one rock into something totally new.
So, the rock cycle is basically Earth's way of recycling. Starts with molten magma cooling down and turning into igneous rocks. Then, these rocks weather away into sediments, which get all compacted together to form sedimentary rocks. Over time, it sinks deep down underneath Earth's surface, where the pressure from the overlying rocks and the heat from the underlying lithosphere are so intense that the rock's structure and chemical composition change, and metamorphic rocks are formed. If those melt, then the whole cycle starts all over again, driven by plate tectonics, erosion, immense pressure and heat.
All right, let's wrap up. Igneous rocks, like granite and basalt, originate from magma. Sedimentary rocks, like sandstone and limestone, form from sediments. Finally, metamorphic rocks, like slate and marble, are transformed from one rock type to another under pressure and heat. All three rock types are in a continuous rock cycle, from igneous to sedimentary to metamorphic and then igneous again.